It's a bit unfair, isn't it? Iñaki Úcar has a degree in engineering, and also in physics, and he's a professional musician and assistant professor at the University Carlos III in Madrid, where he enjoys teaching probability, stochastic processes, Markov chains, tail theories, and anything he comes up with, because this doesn't really exist. He's also a professional musician. He plays clarinet, and he's going to talk about the confirmation bias.
Nos situamos en Inglaterra.
We're in England in 1875. We have a field of science that is developing, especially physics. We have a number of different techniques and technologies that have led to a second industrial revolution. And in this context, we have these two men with this pre-hipster beard, which are going to be the main characters of the story I'm going to be telling you. The first one doesn't need to be introduced. It's James Clerk Maxwell, one of the main scientists of the time. Among other things, because 2 years earlier he had published his main work. He had published a treatise of electricity and magnetism. And later on, the Oliver Heaviside synthesized 4 beautiful equations and developed them in the field of physics. So this theory made exceptional predictions. He unified 2 phenomena that were thought to be separated, and said there were 2 sides of the same coin. He said that light was an electromagnetic wave, and could foresee that light could transmit linear moment, meaning that in the same way that a mass, when it clashes against another mass, can push it away, the light would be able to push as well, and that was something extraordinary at the time. The other main character of our story is William Crookes. He was a chemist, carried out a number of different experiments. He was famous for his ability building vacuum tubes, these type of crystal bottles that were used for different purposes, and he created the cathodic ray tube that was used to discover X-rays, and the old TV sets, of course. But he wasn't a very good scientist. He was a Victorian Chevalier, and he was a spiritist. He liked that field, and he realized that whenever light was shed, light was coming in from the window, the measurements he was carrying out changed, and he started to think why this was so, and he invented this called Crookes radiometer. And it was also called light mill, that has black and reflecting elements to it, or blades, and they're on an axis, and then encapsulated in this crystal sphere where vacuum is applied. So his theory, Maxwell's theory, said that if that light is shed in different ways in both blades, both types of blade, in the reflecting one and black one. So, and there would be a force that would move those, make those blades move. So you see how this device spins, especially when put under the sunlight. And the question, the thing was quite clear. Crookes published a paper with his discovery, and who reviewed it? Well, Maxwell himself, who discovered or developed this theory. Maxwell was fascinated by this invention. He forgot Crookes' spiritist past, and published immediately. Published the paper, and demonstrations were made at the Royal Society where this device was shown, and people at the time said that a new hole to infinity had been opened. But there was a problem here, a problem that was quite important. I don't know if you know this video. This is a classical experiment in psychology in the late 1990s. You see people playing with a basketball, and we're asked to say how many times they pass the ball to each other. The thing is that in the middle of the video you see someone disguised in a gorilla disguise, right? And stops and walks around, and you don't even see it. This experiment has been repeated over and over again in different ways. For instance, it's been carried out with radiologists who've been asked to look for tumors, and they found the tumors. Yes, they do, but they don't see the clear gorilla that we see here on the screen, an X-ray. So, there was a gorilla in here, if you allow me to use this metaphor. And the thing is that the blades turn the other way around. I mean, Maxwell's theory stated, and this is very basic, right, that the reflecting side receives twice as much pressure from the light on the black blades, and therefore it should be spinning in the other sense, in the other direction, in the opposite direction. But that's not the case. Why didn't he realize something so obvious? Well, obviously someone realized this was so. This is the epilogue of the story, and this led to 10 years experimentation where many studies was carried out, and then Osborne Reynolds, a famous scientist of the time, found the key to this effect. And many experiments have been done that found that, for instance, if you took the air out of the system and you made a more perfect vacuum, the blades wouldn't move. If you added air, they wouldn't spin. If you hung them from a thread, they would spin in a specific direction. Right. So there had to be an impact from the air that was still there inside the system, and that was key to all this story I'm telling you about. So the right explanation is actually that there is this very funny effect going on. There's so little air there, but there's little enough for molecules not to find each other. The air molecules that are there don't see each other, they don't interact with each other, but we have enough molecules of air to have this effect called thermal transpiration, found by Reynolds, which means that in the edge of each blade you have a few molecules left that kind of climb through the reflecting side of the blade, which is the coldest one, towards the other side of the blade, which is hotter, and make it move in the direction we've seen on the video. Reynolds obviously wanted to publish a paper about this discovery. He wrote a paper that Maxwell got, and what did Maxwell do? He made a bigger mistake, which was to stop the publication of a paper by Reynolds, and he published his own paper himself using Reynolds' ideas. Of course, fortunately he quoted Reynolds, but he criticized Reynolds' mathematical calculations, which hadn't been published yet, and Reynolds was not very happy about that, as you may understand. Then Maxwell died, and Reynolds wanted to publish a criticism to the criticism of Maxwell's paper. And in the Royal Society, they told him, okay, he just passed, it wouldn't be nice, right, to do that. And that's it. But what I want to tell you about after this story is that one of the evils of science that has brought us this system we have, based on publishing papers, leads me to a conclusion that it's very hard to have this confirmation bias. I mean, all of us have at some point suffered this, maybe a tweet or a post in social media, and we immediately said, oh, I knew it. And then we move on to something else. Because even the main scientists find it hard to recognize only being fully aware of the fact that we have that bias. Only being fully aware on our daily work that we have that bias, it's much easier not to, fall in this temptation, and probably we'll be able to see the gorilla.